Assalamu alaikum. Fahad Hassan, registration number 16TE10. Today the topic of our discussion is window method. Now what is window method? Window method is basically Fourier transform design with window functions. Window functions. Now why was window method developed? It was developed to remedy the undesirable Gibbs oscillation in passband and stopband of designed FIR filters. Developed to remedy the undesirable Gibbs oscillation. Now we will discuss some formulas. Now HW of n equals H of n into W of n. Now HW of n is basically windowed impulse response and H of n is FIR filter cutoff and W of n is the window function. Now for rectangular window, we have W rect of n equal to 1 for minus m less than or equal to n less than or equal to capital M. For triangular window, it is W tri of n equal to 1 minus absolute n divided by capital M. And for Henning window, it is window function for Henning window is (0.5) plus 0.5 cos n pi by m. Now coming towards Hamming window, W ham of n is equal to 0.54 plus 0.46 cos n pi divided by m. Now coming towards the last window function, that is Blackman window. Now Blackman window function is stated as W black of n is equal to 0.42 plus 0.5 cos n pi by m plus 0.08 cos 2 n pi divided by capital M. Now I will discuss some FIR filter cutoff equations. Now these equations are if we have to design a low pass filter, then h of n will be calculated as omega c divided by pi when n equal to 0, and when n not equal to 0, then we have sine omega c into n divided by n pi. Now if we have to design high pass filter, then h of n when n equal to 0 is calculated as pi minus omega c divided by pi, and when n not equal to 0, then it is calculated as sine omega c n over n pi. For band pass, if we have to design a band pass filter, then we have to calculate h of n when n equal to 0 as omega high minus omega low divided by pi, and when n not equal to 0, then h of n equals sine omega h into n divided by n pi minus sine omega l into n divided by n pi. This is the case when n not equal to 0. Now suppose we have to design a band stop filter, then we will calculate h of n as, for band stop, h of n equals pi minus omega h plus omega l divided by pi when n equal to 0, and when n not equal to 0, then it is calculated as minus sine of omega h n over n pi plus sine omega l n over n pi when n not equal to 0. One important thing to note is that h of n obeys the rule of symmetry, means if we calculate h of 1, it is same as h of minus 1. Similarly, for h of 2, it is same as h of minus 2, and so on. Similar is the case with hw of n, which was windowed impulse response, means that if we calculate hw of 1, it is equal to hw of minus 1, and so on. Now coming towards window function w of n, this also obeys the law of symmetry, means if we calculate w of, for example, the Hamming window function of minus 1, it is same as Hamming window function of 1, and so on. That's all for today. In the upcoming lecture, we will do an example in which we have to design an FIR filter. Thank you for watching.